All right, welcome back to trigonometry. We are trying to graph y is equal to 2 tangent of x over 4 minus pi over 5. So just like the notice thing for this, we're going to say, hey, we're graphing a tangent, which means we need the points negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2, because those are the points that tangent really likes to graph with. Okay, so I'm going to ask the question, what does x have to be so that this whole piece here is going to be negative pi over 2? Let's find out. So we have x over 4 minus pi over 5 is equal to negative pi over 2. Let's go ahead and add both sides. So we're going to say we have x over 4 is equal to. Now I need common denominators here, don't I? So we're going to go ahead and get a common denominator here. So I've got 2 pi over 10, right? Right, there's a 2 pi over 10 here, minus, and then we have a 5 pi over 10. Okay, for the 5 times 5 here. 5 times 2, rather. Okay, so it looks like we have 2 minus 5. That's going to be x over 4 is equal to negative 3 pi over 10. Let's go ahead and multiply both sides by 4, and we'll have x is equal to negative 12 pi over 10. All right, let's see what the next one brings. So here we have, we're going to say, again, we're going to say we have x over 4 minus pi over 5 is equal to negative pi over 4. Okay, add pi over 5 to both sides. So we're going to say x over 4 is equal to negative pi over 4 plus pi over 5. And again, I'm going to go ahead and get common denominators. It's going to be a little different than this time. So we end up with x over 4 is equal to, here we have negative 5 pi over 20 plus 4 pi over 20. When I add those together, we get negative 1 pi over 20. So we have x equals negative pi over 20, right? And now I'm going to multiply both sides by 4. So we're going to say x equals negative 4 pi over 20. Okay. I'm going to do one thing over here just before I go because I like patterns. Humans are good at finding patterns. So we're going to say this is actually negative 24 pi over 20. Okay. So just kind of looking at what has to happen here. So, I'm looking at this and it looks like it's getting bigger by about 20 pi over 20 when I'm looking at how to do this. So we'll see what happens. Okay. When I get to 0, we have x over 4 minus pi over 5 is equal to 0. So we have x over 4 is equal to pi over 5. We just add the pi over 5 to both sides. Let's go ahead and multiply both sides by 4. So we're going to say x equals 4 pi over 5. And what we're going to do is we're going to multiply 4 over 4, so we get 16 pi over 20 for my next point here. So if I look at this and I say, well, if I add 20 pi over 20 here, that actually does fit my next spot here. Okay, so I'm pretty happy about that little pattern that we found. Here we're going to say this is x over 4 minus pi over 5 is equal to pi over 4. Let's solve this. So we're going to say x over 4 is equal to pi over 4 plus pi over 5. Get common denominators. Okay, I promise you the fractions get a little bit easier the more you do this. And for those of you who are going on to calculus, about halfway through calculus, you will understand that fractions are constants and they don't have a lot of power in calculus. So they tend to get less powerful. So there's not as much to be afraid of. Where were we? We were looking at pi x over 4 is equal to 5 pi plus 4 pi. I'm going to say that's 9 pi over 20. Okay. And then when I'm going to go ahead and do this, we're going to multiply 9 times 4, and I'm getting 36 from that. So we have x is equal to 36 pi over 20. If I add 20 pi to my 16, I end up with 36 pi over 20. Beautiful. Okay, last one here. So we have x over 4 minus pi over 5 is equal to pi over 2. We're going to add our pi over 5s to both sides. So we have x over 4 is equal to pi over 2 plus pi over 5. Let's go ahead and get some common denominators here. So we have 5 over 5 and 2 over 2. And again, the more often you do this, it gets to be just a little bit easier every time. We have 5 plus 2. That's going to give me 7 pi over 10, I believe. right? Because these are all tens now. If I multiply both sides, we end up with, we have 28 pi over 10. And then I'm going to say, you know what? I'd love to go ahead and do that. We're going to say that's going to add 2 to multiply 2 on both sides here, top and bottom, because I want 20ths, right? And then 28 times 2, well, now I have to think. I know 25 times 2 is 50, and 3 more of that is going to be, so it's bigger than that by that. So I'm looking at 56 pi over 20. That's what x equals. So again, adding 20 pi over 20 to everybody, that makes a lot of sense. We'll go back over here. We'll label the points A, B, C, D, E. Okay, A, B, C, D, E. We'll go up here just to make a double check. We have an amplitude of 2. So as I'm going through and doing this, okay, we have negative, well, we just have point A, point B, point C, point D, and point E, being able to look at what's going on over here. I know that point E and point A are my asymptotes because that's what we set them up to be. I'm going to say that's going to be a 2. This is going to be a negative 2, so we're going to be here and here. And then we can go ahead and graph our tangent, and I look for the shape, and then we still have to have the points that are sitting here. Okay, and that's pretty much how to graph that kind of a problem. Thank you very much for watching, and I will see you in the next video. Good luck.